So how do we deal with a problem like this? This problem right here, I can't do the problem for you, but this has got some decimals in it and stuff. None of the coefficients match. So how will we deal with this? Well, I'm going to create one that's similar. Let's say we got negative 0.8 x plus, so we'll say 3y equals 2. Okay, and then we're going to say x plus 0.25 y equals, I don't like that. I'm going to change it a little bit. I'm going to make it 0.2, and we'll do that. 0.2y equals 4.5. Well, here's what we can do with this thing. First of all, the decimals make it a little hard to read. So there's a couple choices. One is get rid of all the decimals. The way you get rid of all the decimals is you multiply every single part of this equation here by 10, and you end up with negative 8x, because that's 10 times bigger than negative 0.8, plus we got to make that 30y equals 20. That may be a little easier to look at. And this other one, if I multiply everything times 10, this becomes 10x. And that becomes 2y. So plus 2y. And this 4.5 becomes 45. And now I've got something that might be a little easier to think about. So I have choices. I could scale up both equations. So like I could scale this one up by 5 times and this one up by 4 times, and I have the lead coefficient being negative 40 and positive 40. Or I could just scale this bottom one up by 15 times, and then I'd have the y coefficients matching at 30. I can do it either way. Kind of depends on what you're in the mood for. So that's an option for this. So at this point, I'm not going to go ahead and work through that. What I will do, however, is I'm going to go back up to the decimal one and talk about a couple other options. Now, 0.8x, and that's a 1x. Really, it's going to be the same option, honestly. To turn 0.2y into 3y is going to mean I'm going to multiply everything by 15. So I would do the same thing. So if I multiplied everything here by 15, I'll still have decimals. So if you are okay with having decimals, we can do that. So this would end up being, I'll write it up here, 15x. So this I'm going to put up here because I don't have a lot of room. 15x. And this is going to become 3y. And then 15 times 4.5, well, we just got to work out what that is. Let's see what is 15 times 4.5. 15 times 4.5 is going to be 67.5. Back into our question. So 67.5, I believe is what it said. So 67.5. And now I've got two equations with matching coefficients. And so I could subtract the equations and I would get an answer. So I'm going to go ahead and copy it over here. I've got 15x plus 3y equals 67.5. And then I've got negative 0.8 x plus 3y equals 2. So I'm going to subtract. I'm going to subtract this equation from the other one. So that's a negative. So I'm going to make a big subtraction here. That's not supposed to be equal sign. So I'm going to subtract 67 minus 0.5 minus 2 is going to be 65.5. The y's are going to go bye-bye, and I'll have 15 minus negative 0.8x, so that's going to be 15.8x. And now I've just got to divide both sides by 15.8. We'll end up with x equals this kind of messy form, 65.5 over 15.8. Okay, now make it a neat and tidy fraction. I'd probably move my decimal over 1 here and here, multiplying top and bottom by 10. So I ended up with x equals 655 over 158. All right, that's neat. That's a really horrible fraction. I promise you, you will not end up with as horrible a fraction on number 6. But I could then go through and plug that in, and I could find out what y is, or I could scale things so that the x's disappear, and that will work as well. I'll leave it to you to decide whether you'd rather to work with the decimal version or go down here and work with this version. I personally would probably prefer this version because I'm not worrying about keeping track of any decimals. I'll end up with some larger numbers, but it's all workable. So I hope that helped with that.